scattered across our planet, silent sentinels of stone and mystery stand in defiance of conventional understanding. They are the architectural anomalies, the engineering impossibilities, the mathematical marvels that whisper of knowledge that should not have existed in their time. These are the ruins that mainstream archaeology acknowledges, but cannot explain. Monuments that challenge the very foundations of our understanding of human history and capability. From the windswept highlands of Bolivia to the depths of the Japanese Sea, from the jungles of Cambodia to the barren deserts of Egypt. These structures stand as testament to possibilities that modern science has been reluctant to consider. They are not the product of fevered imagination or pseudo-scientific speculation, but physical reality, stone and mortar, angles and alignments, precision and purpose that can be measured, documented, and verified. Yet the methods of their creation remain shrouded in mystery. Consider the megalithic blocks at Baalbek in Lebanon, stones weighing up to 1,650 tons, cut with laser-like precision and moved across impossible terrain, only to be stacked with such perfection that not even a razor blade can penetrate their seams. Modern engineering firms freely admit that even with today's most advanced technology, moving such massive monoliths would present nearly insurmountable challenges. Yet there they rest, having remained in place for millennia. Or contemplate the enigmatic ruins of Puma Punku in Bolivia, where H-shaped blocks of andesite and granite, some of the hardest stone on Earth, have been cut with such mathematical precision that they suggest machining capabilities that should not have existed in pre-Columbian South America. The precision is measured not in millimeters but in microns, with right angles crafted to within 1/2 of a single degree of perfect. Beneath the waters off Japan's Yonaguni Island lie massive stepped structures with perfect straight edges and right angles that would require precise cutting and placement. Yet mainstream geology insists they are merely natural formations, despite their architectural appearance and their alignment with cardinal directions. Similar underwater anomalies dot coastlines worldwide, from India to Cuba, suggesting the possibility of advanced civilizations predating the dramatic sea level rise that occurred at the end of the last ice age. In the deserts of Peru, the Nazca lines stretch across miles of barren landscape, massive geoglyphs depicting animals, geometric patterns, and straight lines spanning distances so vast they can only be properly viewed from high above the earth. Their creation required not only artistic vision, but a sophisticated understanding of large-scale geometry and the ability to maintain perfect proportions without the benefit of an aerial perspective. The Great Pyramid of Giza incorporates mathematical constants like pi and phi into its very structure, aligns perfectly with true north, with an accuracy greater than that of the modern meridian building at Greenwich Observatory, and exhibits a level of precision that would challenge modern builders, equipped with laser transits and GPS technology. Yet we are asked to believe it was constructed using copper tools, wooden rollers, and ropes by a civilization that had not yet invented the wheel. These are not isolated anomalies, but components of a global pattern, a mosaic of archaeological mysteries that, when viewed together, suggest the possibility that conventional chronologies of human technological development may be fundamentally incomplete. They hint at forgotten chapters in the human story, at lost knowledge, at capabilities that emerged, flourished, and then vanished from the historical record, leaving only their most durable creations behind as evidence of their existence. The purpose of this exploration is not to propose sensational theories or to dismiss the valuable work of conventional archaeology. Rather, it is to confront the physical evidence that exists in stone and earth around our world, evidence that deserves honest assessment, even when it challenges established paradigms. It is to ask the questions that arise naturally when one stands before these monuments. Who created them? How were they built? And perhaps most importantly, what does their existence tell us about the true history of human civilization? Join us as we journey to the most perplexing archaeological sites on Earth, the places where stone and science collide, where conventional explanations falter, and where the mysteries of our past await those willing to look beyond established narratives to the physical evidence that has endured through millennia. The fortress of Sacsayhuaman stands on a steep hill overlooking the ancient Incan capital of Cusco, Peru. But unlike most Incan constructions, this site defies conventional archaeological understanding. Its most impressive feature is a massive zigzagging wall composed of megalithic blocks, some weighing more than 200 tons, fitted together with such precision that not even a sheet of paper can be inserted between them. More astonishing still is the complex polygonal nature of these stones, with some blocks having up to 12 perfectly cut faces that interlock seamlessly with their neighbors in 3 dimensions. Spanish conquistadors, upon encountering this marvel in the 16th century, believed it must have been constructed by demons or made through magic. Modern engineers, despite our technological advantages, remain equally perplexed. The level of precision evident in these stone junctions exceeds what would be necessary for structural integrity. The perfection appears to be an intentional demonstration of technical capability rather than functional necessity. Conventional archaeology attributes these structures to the Inca, suggesting they were built using stone hammers, fiber ropes, and bronze tools. Yet experimental archaeology has repeatedly failed to reproduce similar results using these methods. The stones are primarily andesite and diorite materials that register between 6 and 7 on the MOS scale of hardness, making them resistant to copper and bronze tools, the hardest metals available to pre-Columbian South American cultures. Even more puzzling is how these massive stones were transported. Many weigh between 50 and 200 tons and show no signs of damage that would occur during dragging. The quarries have been identified between 10 and 50 miles away, across river valleys and steep mountain terrain that would make conventional dragging nearly impossible. Yet there they stand, silent testimonies to capabilities that should not have existed in their time. Halfway around the world, the enigma deepens at Baalbek in Lebanon. While the visible ruins are Roman, they stand upon a foundation of megaliths that predate Roman occupation. The most massive of these stones, as the Stone of the South or the Stone of the Pregnant Woman, weighs approximately 1,000 tons. Nearby lies an even larger monolith, still attached to the bedrock, estimated at over 1,650 tons, making it the largest cut stone in the world. For perspective, the largest modern cranes can lift approximately 1,200 tons under ideal conditions. Yet these ancient stones were not only quarried, but transported uphill and placed with such precision that mortar was unnecessary. Roman technology, advanced as it was, has never been documented to move stones of this magnitude. Indeed, the Romans themselves built their temple upon this pre-existing platform, never attempting to replicate the megalithic engineering beneath their own construction. The mystery extends to Egypt, where the Aswan quarries contain the famous, unfinished obelisk, a single piece of granite over 137 feet long, weighing approximately 1,200 tons. Had it been completed and erected, it would have been the largest monolith ever raised. The tools and methods required to extract such a massive stone remain controversial. Granite has a hardness of 7 on the MOS scale, making it resistant to copper and bronze tools supposedly used by ancient Egyptians. More perplexing are the precision-cut granite boxes found in the Serapeum at Saqqara. These massive containers, weighing between 70 and 100 tons each, have been hollowed out with such precision that their inner surfaces are perfectly flat, with right angles accurate to within a fraction of a degree. The surfaces are so perfect that they appear to have been machined rather than handcrafted. Some boxes show evidence of drilling, with boreholes maintaining a consistent diameter throughout their depth, feature difficult to achieve even with modern tools when drilling through granite. Perhaps The most challenging megalithic site to explain is Göbekli Tepe in southeastern Turkey. Carbon dated to approximately 9600 BCE, this complex predates pottery, metallurgy, writing, and even agriculture. The site features massive T-shaped pillars weighing up to 20 tons, arranged in precise circles and decorated with sophisticated carvings of animals and abstract symbols. According to conventional archaeological timelines, the hunter-gatherers of this period should not have possessed the social organization, architectural knowledge, or resources to create such structures. What unites these disparate sites by thousands of miles and thousands of years is the presence of engineering capabilities that defy conventional archaeological understanding. They exhibit precision that would challenge modern stonemasons equipped with power tools and measuring devices. They involve the quarrying, transportation, and placement of stones so massive that they would present significant challenges even to modern construction firms with hydraulic cranes and diesel engines. The conventional explanations, copper tools, wooden rollers, ropes, and vast numbers of workers have been repeatedly challenged by experimental archaeology. Attempts to reproduce these methods have consistently failed to achieve comparable results, particularly regarding the precision, cutting of hard stone, and the transportation of supermassive monoliths across difficult terrain. This has led some researchers to propose alternative theories. Engineer Christopher Dunn has suggested that the ancient Egyptians may have possessed advanced machining capabilities, pointing to evidence of what appear to be tool marks consistent with lathe turning and precision sawing in granite artifacts. Others have proposed the existence of lost technologies for stone softening, acoustic levitation, or other techniques not recognized by conventional science. Mainstream archaeology has largely rejected these proposals, sometimes without thorough investigation, preferring to maintain that these monuments were created using primitive tools and vast human labor. Yet the physical evidence, the precision joins, the impossibly heavy stones, the machining marks in ultra-hard stone continues to challenge this consensus. As we stand before these megalithic marvels, we must confront a troubling question. Is our understanding of ancient technological capabilities fundamentally flawed? Have we underestimated our ancestors' ingenuity and knowledge? Or is there another explanation for these architectural anomalies, one that might force us to reconsider the conventional narrative of human technological development? And if these stone mysteries represent technologies and capabilities that have been lost to time, what other knowledge might have vanished from human memory, leaving only these massive monuments as testimony to their existence? Beneath the waters of Yonaguni Island, Japan, lies a geological enigma that has divided scientific opinion since its discovery in 1987. Divers exploring the area encountered what appears to be a massive stepped structure, a series of terraces, ramps, and formations carved from the bedrock of the ocean floor. The largest feature, known as the monument, measures approximately 490 feet long and 130 feet wide, with multiple tiers rising to a height of 90 feet. What makes the Yonaguni Formation so controversial is its geometric character. The structure contains nearly perfect right angles, straight edges that extend for dozens of meters, and precise parallel faces, features rarely found in natural formations. Most striking is a massive platform with steps leading to its summit, flanked by what appear to be regularly spaced support columns. The entire complex aligns perfectly with cardinal directions, a characteristic common to intentionally designed structures, but extraordinarily rare in natural formations. Masaki Kimura, a marine geologist from the University of the Ryukyus, has spent over 2 decades studying the monument. After thousands of dives, he maintains that while the formation began as a natural feature, it shows unmistakable signs of human modification: tool marks, drainage channels, quarried stones, and even what appears to be a ceremonial road. Most compelling is his documentation of what seems to be a carved stone face, measuring 23 feet in height and width, with clearly distinguishable eyes, nose, and mouth. Conventional geology, however, insists the formations are entirely natural, result of natural fracturing in the sandstone bedrock, combined with the effects of erosion. Yet this explanation struggles to account for the regularity of the angles, the consistency of the terrace heights, and the precise alignment with cardinal directions. If the Yonaguni monument is artificial, even partially, it would have been constructed when the area was above sea level at least 10,000 years ago, during the last ice age, when sea levels were approximately 130 feet lower than today. This timeline directly contradicts the conventional archaeological understanding of Japanese prehistory, which holds that the region was inhabited only by hunters until much later periods. The technical capabilities required to modify such massive stone structures would suggest a level of social organization and engineering knowledge not thought to exist in this region during the Paleolithic era. The controversy surrounding Yonaguni is not isolated. Off the coast of India, in the Gulf of Cambay Kalmhat, marine archaeologists have discovered evidence of what appears to be a vast underwater city. Side-scan sonar has revealed geometric structures covering an area of approximately 5 square miles, including what seem to be the foundations of massive buildings, a network of streets, and even a system of drainage channels. Dredging operations have recovered artifacts, including pottery fragments, stone tools, beads, sculpture fragments, and even human remains. Carbon dating of the recovered materials suggests an age of at least 9,500 years, making this site, if confirmed as artificial, older than the earliest known urban civilizations in Mesopotamia and the Indus Valley by thousands of years. Conventional archaeology has responded with skepticism, suggesting the sonar images may represent natural formations and that the artifacts could have been carried into the area by ancient rivers. Yet the geometric regularity of the structures, the recovery of carved stone artifacts, and the apparent urban planning evident in the layout all suggest intentional human construction rather than natural formations or scattered debris. Similar underwater anomalies have been documented around the world. Off the coast of Cuba, deep-sea remote-operated vehicles have captured images of what appear to be geometric structures at a depth of over 2,000 feet, including straight lines, right angles, and pyramidal forms arranged in patterns reminiscent of urban planning. Near Bimini in the Bahamas, a formation known as the Bimini Road consists of regularly shaped limestone blocks, arranged in what appears to be a deliberately constructed pathway leading toward the shore. What unites these submerged sites is their implication for human prehistory. If they are indeed artificial structures, they would have been constructed when sea levels were much lower during or before the end of the last ice age, approximately 10,000 to 12,000 years ago. This time frame predates the conventional dating for the emergence of complex civilizations by thousands of years. The possibility that advanced societies capable of monumental stone construction existed during the Ice Age forces us to confront a troubling question. Could entire civilizations have been lost to rising seas as the ice sheets melted? Geologists confirm that sea levels rose by approximately 400 feet as the last ice age ended, a process that inundated vast coastal regions around the world, precisely the areas where early human settlements were most likely to develop due to abundant food resources and ease of transportation. If advanced coastal civilizations existed during this period, their remains would now lie under hundreds of feet of water, largely inaccessible to conventional archaeology. Our understanding of human prehistory would then be based primarily on the remains of inland cultures that may have been less technologically advanced than their coastal contemporaries. This perspective is supported by geological evidence. The end of the last ice age witnessed not just gradually rising seas, but catastrophic flooding events periods when meltwater that had accumulated behind ice dams suddenly broke through, releasing enormous volumes of water that could raise global sea levels by several meters in a matter of days or weeks. The most dramatic of these events, known as Meltwater Pulse 1A, raised global sea levels by approximately 60 feet over a period of about 500 years, a geological instant. For any coastal civilizations existing during this period, such rapid sea rise would have been catastrophic, not a gradual retreat allowing for adaptation, but a series of devastating floods that could obliterate entire settlements within a single generation. The cultural memory of such events might be preserved in the remarkably consistent flood myths that appear in cultures around the world, from the biblical account of Noah to the Mesopotamian epic of Gilgamesh, from Greek legends of Duk to the Maya Papovuh. As underwater imaging technology advances and marine archaeology becomes more sophisticated, these submerged sites may yield further evidence that forces a fundamental reconsideration of human prehistory. The question remains, are we seeing natural formations that coincidentally resemble human structures? Or are we glimpsing the remnants of lost civilizations, advanced societies that rose, flourished, and were then literally washed from the pages of history by the inexorable rise of the seas? And if such societies existed, what knowledge, technologies, and understanding might they have possessed that vanished with them beneath the waves? In the Altiplano of Bolivia, at an elevation of over 12,000 feet, lie the ruins of Puma Punku, a site that has confounded archaeologists since its discovery. Part of the larger Tiwanaku complex, Puma Punku consists of megalithic blocks of andesite and granite scattered across the landscape like toys discarded by a giant child. But it is not their size that most perplexes researchers, it is their impossible precision. The stone blocks of Puma Punku exhibit cuts, grooves, and drill holes that appear to have been created with machine-like accuracy. Perfect right angles, precision-cut channels, and standardized dimensions suggest fabrication, methods far beyond what should have been possible with the stone tools attributed to the Tiwanaku culture. Some blocks feature intricate H-shaped cuts, with internal corners that would be challenging to produce even with modern power tools. More astonishing still is the mathematical precision evident throughout the site. The blocks were created with such exactitude that they fit together with seamless joints, despite their complex geometry. Many feature standardized cuts and indentations that appear to be modular in designs, if they were components of a prefabricated structure meant to be assembled like a massive three-dimensional puzzle. Conventional archaeology dates Puma Punku to approximately 500 to 600 CE and attributes its construction to the Tiwanaku civilization, yet the technical capabilities required to work such hard stone with such precision far exceed what should have been available to a Bronze Age culture. The andesite used for many of the blocks registers 6 to 7 on the Mohs scale of hardness, making it resistant to the copper and bronze tools supposedly used by the Tiwanaku. Adding to the mystery is the site's condition. Unlike many ancient ruins that show evidence of gradual decay, Puma Punku appears to have been dismantled by some cataclysmic force. Massive stone blocks weighing up to 100 tons lie scattered as if flung by a giant hand. Some researchers suggest evidence of tsunami-like damage, despite the site's high-altitude location far from any ocean. The technical anomalies extend far beyond Bolivia. At Aswan in Egypt, the ancient granite quarries contain evidence of stoneworking techniques that defy conventional explanation. The most visible example is the unfinished obelisk, a massive monolith still attached to the bedrock. What perplexes researchers are the production marks visible in the quarry, evidence of cutting and drilling techniques in granite that would challenge even modern tools. Nearby, the Serapeum at Saqqara contains 25 massive granite and basalt boxes, each weighing between 70 and 100 tons. These boxes have been hollowed out with such precision that their inner surfaces are perfectly flat, with right angles accurate to within 1/10 of a degree. The surfaces are so perfect that they appear to have been machined rather than handcrafted. Some boxes show evidence of precision drilling, with boreholes maintaining a consistent diameter throughout their depth, a feature difficult to achieve, even with modern equipment. When drilling through granite, the Great Pyramid of Giza presents similar technical anomalies. The base of the pyramid is level 2, within 2.1 centimeters across its entire 13-acre footprint, a degree of precision that would be challenging even with modern laser leveling equipment. The pyramid's sides are aligned to true north with an accuracy of 3/60th of a degree, more precise than the modern meridian building at Greenwich Observatory. Inside the pyramid, the granite coffer in the king's chamber exhibits tool marks consistent with precision machining rather than primitive hand tools. Its interior and exterior surfaces are perfectly flat and parallel, with right angles that deviate by less than 1/50th of an inch. Christopher Dunn, an engineer and expert in precision machining, has demonstrated that the coffer's interior corners show radii consistent with modern milling techniques rather than hand chiseling. Perhaps most perplexing are the precision-drilled holes found throughout ancient Egyptian monuments in the underground chambers beneath Saqqara. Archaeologists have documented perfectly straight holes drilled through granite, with no evidence of the spiraling pattern that would result from rotary drilling. The holes maintain a consistent diameter throughout their depth and show no signs of the tapering that would occur with primitive drilling methods. Similar technical precision appears at sites around the world. The megalithic blocks at Baalbek in Lebanon are cut so precisely that they fit together without mortar, despite weighing up to 1,000 tons each. The stone walls at Ollantaytambo in Peru feature complex polygonal joinery that maintains uniform precision despite irregular shapes. The massive stone spheres of Costa Rica, some weighing over 16 tons, have been shaped into perfect spheres, with deviations of less than 2 millimeters from mathematical perfection. These examples of precision stonework force us to confront an uncomfortable question. How were ancient cultures, supposedly limited to copper tools, stone hammers, and wooden mallets, able to achieve levels of precision that would challenge modern machinists equipped with power tools and measuring instruments? Conventional explanations typically invoke vast human labor, trial and error techniques, and simple tools used with extraordinary patience and skill. Yet experimental archaeology has repeatedly failed to reproduce these results using the methods and materials supposedly available to ancient builders. Modern attempts to replicate such precision in hard stone using primitive tools have consistently fallen short, particularly regarding the perfect flatness of surfaces, the precision of internal right angles, and the consistent diameter of deep drill holes. This has led some researchers to propose alternative theories. Engineer Christopher Dunn has suggested that the ancient Egyptians may have possessed advanced machining capabilities, pointing to evidence of what appear to be tool marks, consistent with lathe turning, precision sawing, and industrial drilling in granite artifacts. Others have proposed the existence of lost technologies for stone softening, acoustic manipulation, or other techniques not recognized by conventional science. Most controversial are suggestions that some of these sites may represent the work of much earlier, more technologically advanced civilizations whose existence has been erased from conventional history by catastrophic events like the rapid sea level rise at the end of the last ice age. Mainstream archaeology has largely rejected these proposals, sometimes without thorough investigation, preferring to maintain that these monuments were created using primitive tools and vast human labor. Yet the physical evidence, the precision joins, the perfectly flat surfaces, the machine-like tool marks in ultra-hard stone, continues to challenge this consensus. As we contemplate these precision-crafted stones, we must ask, are we missing something fundamental about the technical capabilities of ancient cultures? Have we underestimated their knowledge and innovation? Or do these architectural anomalies point to capabilities and technologies that have been lost to time, leaving only their most durable creations as evidence of their existence. The Great Pyramid of Giza is not merely a massive tomb, but a structure that appears to encode advanced mathematical knowledge that should not have existed at the time of its construction. Its dimensions incorporate the mathematical constant pi with remarkable precision. The ratio of the pyramid's perimeter to its height multiplied by 2 gives 3.14159, an accurate representation of pi 26 decimal places. Similarly, the dimensions of the king's chamber utilize the golden ratio, phi, a mathematical proportion not formally discovered until the time of the ancient Greeks. Thousands of years later, more astonishing is the pyramid's geodetic precision. The structure encodes the dimensions of the Earth with surprising accuracy. The pyramid's height multiplied by 43,200 approximates the polar radius of the Earth, while its perimeter divided by 43,200 represents the equatorial circumference measurements that modern science only determined precisely in the 19th century, using advanced surveying techniques and mathematics. The number 43,200 itself is not arbitrary, but represents a key astronomical value. It is precisely 1/100th of the number of seconds in a 12-hour period, and relates to the precession of Earth's axis. This astronomical phenomenon, the gradual shift of the Earth's axial orientation that takes approximately 25,920 years to complete, was supposedly unknown until discovered by the Greek astronomer Hipparchus in 127 BCE, yet appears to be encoded in monuments that predate him by thousands of years. Similar mathematical precision appears at sites worldwide. The temples of Angkor in Cambodia incorporate astronomical alignments and mathematical proportions that mirror the constellation Draco as it appeared 12,000 years ago. The ancient megalithic site of Nabta Playa in Egypt's Nubian desert, dating to approximately 7,000 BCE, includes stone arrangements that precisely track the summer solstice and the rising of key stars. Astronomical knowledge that should have been beyond the capabilities of the early Neolithic cattle herders, attributed with its creation. Perhaps most confounding are the Nazca lines of Peru, massive geoglyphs created between 500 BCE and 500 CE by removing the reddish surface pebbles to reveal the lighter-colored earth beneath. These designs include enormous animal figures, geometric patterns, and straight lines that extend perfectly straight for miles across the desert floor. Some lines maintain perfect straightness, despite traversing uneven terrain, a feat that would require sophisticated surveying capabilities to achieve without an aerial perspective. The precision of these lines has led some researchers to suggest they were created using some form of aerial guidance, technological capability not thought to exist in pre-Columbian Peru. More conventional explanations involve the use of simple surveying techniques, yet experimental archaeology has struggled to reproduce the perfect straightness of the longest lines using only the tools and methods supposedly available to the Nazca culture. Beyond these physical monuments, ancient texts contain knowledge that appears anachronistic within conventional historical frameworks. The Surya Siddhanta, an ancient Sanskrit text on astronomy dating to at least 1000 BCE, contains calculations for the Earth's diameter that are 99.8% accurate compared to modern measurements. It also provides the precise orbital periods of all visible planets, accurate to within a few decimal points of current astronomical values. The Antikythera mechanism, recovered from an ancient Greek shipwreck and dated to approximately 100 BCE, represents perhaps the most sophisticated ancient technological artifact ever discovered. This astronomical calculator contains at least 30 precisely engineered bronze gears, arranged in a differential system that track the positions of the sun, moon, and planets with remarkable accuracy. It could predict eclipses and account for the irregular orbit of the moon using a mechanical implementation of advanced mathematical principles. the level of astronomical and mathematical knowledge encoded in this device would not be seen again in human history until the development of mechanical astronomical clocks in 14th century Europe nearly 1,500 years later. Yet there it was, fully realized. With no clear evolutionary precursors in the archaeological record, these examples of encoded knowledge force us to confront a troubling question. How did ancient cultures acquire mathematical, astronomical, and geodetic information that, by conventional understanding, they should not have possessed? The precision of this knowledge often exceeds what could have been determined through simple observation or trial and error. Within the technological constraints of their time, some researchers propose these anomalies suggest the existence of a sophisticated predecessor, Civilization 1, whose knowledge was preserved fragmentarily after some catastrophic collapse. Others point to the possibility of knowledge transfer from more advanced, contemporaneous cultures whose existence has not been recognized by conventional archaeology. The most controversial theories involve the possibility of non-human sources of information, whether interpreted as extraterrestrial contact or as interaction with advanced human civilizations from before recorded history. Conventional archaeology has typically explained these anomalies through a combination of coincidence, exaggerated pattern recognition, and attributing more sophisticated observational capabilities to ancient cultures than previously acknowledged. Yet the sheer number of these instances of encoded knowledge, their global distribution, and their mathematical precision continue to challenge these explanations. Perhaps most perplexing is why this advanced knowledge appears encoded in stone, in monument, rather than in more accessible forms. If ancient cultures possessed such sophisticated understanding of mathematics, astronomy, and geodesy, why encode it in the dimensions of massive stone structures rather than in written texts or practical applications? One possibility is that the encoding was an actual method of preserving crucial knowledge against the ravages of time and cultural collapse. This perspective gains credence when we consider that many of these monuments have indeed survived, when more fragile records have been lost. The Great Library of Alexandria, with its hundreds of thousands of scrolls representing the accumulated knowledge of the ancient world, was destroyed by fire. The vast majority of Maya codices were burned by Spanish conquistadors. The knowledge contained in these lost works, mathematical, astronomical, historical, technological, represents an incalculable loss to human understanding. In contrast, the stone monuments with their encoded mathematical and astronomical knowledge have endured for millennia. If ancient builders intentionally incorporated this information into their most durable creations, it suggests they understood something profound about the fragility of civilization and the importance of preserving crucial knowledge against catastrophe or collapse. As we contemplate these monuments and their encoded knowledge, we must consider a disturbing possibility. Could they represent the deliberate preservation of advanced understanding by cultures that anticipated their own demise? Are these massive stone structures not merely temples, tombs, or demonstrations of power, but time capsules of knowledge, messages sent forward through millennia to future civilizations, capable of decoding their mathematical and astronomical content? And if so, what does that suggest about the cyclical nature of human civilization and the recurrence of catastrophes, capable of erasing accumulated knowledge from all but the most durable records? Throughout the history of archaeology, a curious pattern emerges when confronted with evidence that contradicts established chronologies or capabilities. A pattern of institutional resistance, methodological dismissal, and in some cases, active suppression of anomalous findings. This pattern is not the result of conspiracy, but of the natural conservatism of scientific disciplines, the institutional pressures that shape academic careers, and the human tendency to defend established paradigms against contradictory evidence. Consider the case of Göbekli Tepe in Turkey. When German archaeologist Klaus Schmidt began excavating this site in 1994, he uncovered massive stone pillars arranged in circular patterns, carved with sophisticated animal reliefs and abstract symbols. Carbon dating placed the site's construction at approximately 9600 BC, in nearly 7,000 years before Stonehenge and the Egyptian pyramids. And most importantly, predating the agricultural revolution that supposedly made such monumental construction possible. For years, Schmidt's findings were treated with skepticism by the archaeological establishment. The site contradicted the fundamental narrative that complex monument building required settled, agricultural societies with specialized labor and hierarchical organization. Yet as excavation continued and dating was confirmed through multiple methods, the reality of Göbekli Tepe could no longer be denied, rather than prompting a fundamental reassessment of human prehistory. However, the site was gradually incorporated into the established framework, with minimal disruption to existing chronologies. A more troubling pattern emerges when we examine archaeological findings that directly contradict established timelines of human presence or technological capability. At Hueyatlaco in Mexico, sophisticated stone tools were discovered in geological strata dating to over 250,000 years ago, hundreds of thousands of years before Homo sapiens supposedly evolved. The site was excavated in the 1960s by a team led by archaeologist Virginia Stain McIntyre, who used multiple dating methods, including uranium series dating, fission track dating, and tetrahydration dating, all of which consistently indicated an age of approximately 250,000 years. The response from the archaeological establishment was swift and decisive. Stain McIntyre's findings were rejected, her professional reputation damaged, and her academic career effectively ended. The site and its anomalous dating were marginalized in archaeological literature, and eventually forgotten by all but those specifically interested in archaeological anomalies. Similar fates have befallen researchers associated with the Calico Early Man site in California, the Cerruti Mastodon site in San Diego, and numerous other locations where evidence suggests human presence in the Americas far earlier than the conventional timeline allows. This pattern of rejection extends to underwater archaeology as well. When marine geologist Masaki Kimura presented evidence suggesting human modification of the Yonaguni Monument off the coast of Japan, mainstream geology responded not with thorough investigation but with blanket dismissal, insisting the formations must be entirely natural, despite their geometric regularities and alignment with cardinal directions. Similar treatment has been given to underwater structures in the Gulf of Cambay, off the coast of Cuba, and near Bimini, in the Bahamas. What makes this pattern particularly troubling is its selectivity. Archaeological findings that support established chronologies are readily accepted and incorporated into textbooks and museum exhibits, while those that contradict it are subjected to extraordinary levels of scrutiny, dismissed on technical grounds, or simply ignored. This creates a self-reinforcing system where the established narrative is continuously confirmed while contradictory evidence is systematically excluded. This institutional resistance creates barriers for researchers who attempt to investigate archaeological anomalies. Funding for excavations or research projects that might challenge conventional chronologies becomes difficult to obtain. Publications in peer-reviewed journals become nearly impossible. Academic positions become jeopardized. The result is a chilling effect on the exploration of evidence that might lead to fundamental revisions of our understanding of human prehistory. Perhaps most concerning is how this pattern affects public understanding of archaeology and human history. When confronted with these archaeological anomalies, many people perceive a choice between two extremes. Either accept the conventional narrative despite its inability to explain these sites, or embrace sensationalistic alternative theories involving ancient aliens or lost advanced civilizations. This false dichotomy obscures more nuanced possibilities, that human technological development may have followed a more complex, non-linear path than currently recognized. that capabilities and knowledge may have been developed, lost, and rediscovered multiple times throughout prehistory, that conventional chronologies may require significant revision without necessitating extraterrestrial intervention. The situation is further complicated by the genuine presence of pseudoscientific claims in alternative archaeology. Some proponents of revised chronologies or lost civilizations do indeed make unsupported assertions, misrepresent evidence, or propose theories that contradict well-established physical laws. These problematic claims provide justification for dismissing all challenges to conventional archaeology, regardless of their evidential basis. Yet the physical evidence remains massive stones cut and moved with inexplicable precision. Underwater structures that appear artificial, yet must predate known civilizations if they are. Astronomical knowledge encoded in monuments with an accuracy that should have been impossible to achieve at the time of their construction. These are not matters of interpretation, but physical realities that can be measured, documented, and verified. As we consider these unsolvable ruins and the institutional resistance to their implications, we must confront a disturbing possibility that our understanding of human prehistory may be fundamentally incomplete, not because the evidence doesn't exist, but because it has been systematically excluded from the conventional narrative. This is not to suggest that mainstream archaeology is fundamentally flawed or that all alternative theories are correct. Rather, it is to recognize that science advances not through the rigid defense of established paradigms, but through the honest investigation of anomalous evidence, the data points that don't fit, the findings that contradict expectations, the physical realities that challenge theoretical frameworks. The ruins we've explored in this journey, from the precision-cut stones of Pumapunku to the megalithic platforms of Baalbek, from the submerged structures of Yanaguni to the mathematically encoded Great Pyramid, deserve this honest investigation. They deserve to be approached, not with predetermined conclusions about what is or isn't possible, but with open inquiry into what they might tell us about our human past. For in these stone enigmas may lie not just curiosities of ancient engineering, but crucial insights into the true capabilities, achievements, and challenges of our ancestors. And perhaps most importantly, they may contain warnings about the fragility of civilization itself, about how knowledge can be lost, achievements forgotten, and entire societies erased from memory, leaving only their most durable creations as testimony to their existence. As we stand before these monuments to forgotten capabilities, we must ask ourselves, what might we be missing in our understanding of human history? What knowledge might have been developed and then lost? And what might these ruins tell us about our own civilization's future, if only we are willing to listen to their stone whispers?